In this video, we are going to be talking about division. So we're going to start off exactly the same way we started off with multiplication. We're going to look at a definition. And again, the Common Core standards have a very nice definition. So if you think about our definition of multiplication, multiplication was the total number of things if we know groups and we know things in groups. Well, for division, we're going to basically undo that. If we know the total number of things, then we can figure out what happens if that total number of things is split equally into a number of groups, or if that total number of things is split into an equal number with groups with an equal number in each one. So I have two different ways of thinking about this. I can split it equally into a certain number of groups, or I can be looking for the groups if I know how many things are in the groups. So two different ways of expressing division, and we're going to look at both of those and practice writing some word problems. Just like multiplication in our, this is in the South Carolina standards here. Just like multiplication in our standards begins in third grade, division in our standards begins in third grade as well. And so we're going to be looking at the multiplication tables and then the division facts that relate to those. And if you notice in the part about the word problems, we have equal groups, area array, and number line, and we're looking at that with multiplication. That's what we looked at before, but also related division facts. So that's where we're going to be looking for the opposite of what we did here. So just like addition and subtraction go hand in hand, and we introduce those in the same grade level, multiplication and division go hand in hand, and we introduce those in the same grade level as well. Okay, so look at this definition of division. So I have any whole numbers a and b. B cannot be 0. A divided by b equals this number c if and only if c is the unique whole number such that b times c equals the a that we had to start with. So again, you can see how the division and the multiplication are related. So looking at some vocabulary words, a is the dividend, b is the divisor, and c is the quotient. So this is true if and only if the quotient times the divisor is going to give me the dividend, right? Quotient times divisor equals dividend. So we start off with this notation in third grade using that division symbol. And later on, we're going to learn that fractions are just another way of writing division. And we're also going to be looking at some long division. All right, we have three models for subtraction for division. So just like we have groups and things in groups, that's our two models that we have here. And the missing factor model could go with either one of those. So just like in subtraction, we had to be able to rearrange subtraction to be a missing addend model. We're going to be able to rearrange division to be a missing factor model. Okay, so let's do some examples. First is our set or our partition model. That was the first type. So suppose we have 18 cookies and we want to give an equal number of cookies to each of our three friends, Bob, Dean, and Charlie. The question then, how many should each person receive? Okay, so let's see how this relates to multiplication. So in multiplication, the answer is the total number of things. In division, the total number of things is given. All right, and in multiplication, we said we have groups and we have things in groups. So looking at this problem, what are our groups? That's our three friends. In this case, we know how many groups. There are three. And how many should each person receive? Well, that's the things in the groups. That's the cookies. And this is what we don't know. This is what we're looking for. So in this set model, we know the number of groups and we're looking for the number of things in each of our groups. It's really important to notice this word equal right here. It is very true that I could split my 18 cookies between Bob, Dean, and Charlie. Bob is going to get 2, Dean is going to get 7, and Charlie is going to get 9. I did, in fact, share my cookies with my friends, but I did not give anybody an equal number. So this is not going to be a division example. In order for it to be in a division example, we have to give an equal number to each person. Okay, let's look at what that's going to look like with our blocks. So I have 18 cookies here. And I have my 3 friends, Bob, Dean, and Charlie. So if I'm a 3rd grader, I don't automatically know how many cookies each person should get. So what we're going to do is we're going to share. So Bob gets 1, Dean gets 1, Charlie gets 1. And I'll just do that again. Bob gets 1, Dean gets 1, Charlie gets 1. And I'll keep doing that until I run out of cookies. So the way you're going to illustrate this on your test, because obviously you can't move things around while I'm grading your test, right? I can't watch you do that. So you're going to label the cookies maybe BDC, BDC, BDC for Bob, Dean, Charlie. Maybe you're going to label them 1, 2, 3, 1, 2, 3, 1, 2, 3. Maybe you're going to go 1, 1, 1, 2, 2, 2, 3, 3, 3. Just in some way, make sure that I can tell that the way you're doing this is giving 1 cookie to each friend and then going back and giving a 2nd cookie and then going back and getting a 3rd cookie, right? It's important that you go 1 by 1 to the friends. So Bob, Dean, and Charlie all have an equal number of cookies, and that's the answer to the question. How many cookies does each person have? 1, 2, 3, 4, 5, 6. Each person has 6 cookies. The answer to this question is 6. Okay, now I want you to try one using 24 divided by 4. Okay, so think about what we looked at in the last one. The 24, the number that's given in our division problem is the total. And look at what we knew here. We knew how many groups. We wanted to know how many things in each group. So we know how many groups. We want to know how many things in each group. All right, and remember, it's very important that each of your groups gets an equal number of things. Okay, so I want you guys to write one, and we are not going to use anything food related. All right, 24 divided by 4, looking for how many things in each group, not food related. Okay, so let's look at this one, the solution with the blocks. So I had 4 groups, whatever those 4 things were that you put in your word problem. And I'm going to need to split my blocks equally between those 4 groups. So as a 3rd grader, with all my manipulatives on my desk or on the table or however it is you have your room set up, I'm going to start dividing them out, putting 1 in each group over and over and over again until I run out, right? Maybe you're going to, on your test paper, maybe you're going to draw arrows. Just somehow make sure that I can tell that each group is getting 1, and then you're going back and putting a 2nd thing in each group, and then going back and putting a 3rd thing in each group. To be honest with you, with your 3rd grader, it doesn't matter if they grab them like I did in a line or they just grab them sporadically. The important thing is they put 1 in each group until they use them all up. All right, so how many things are in each group? 1, 2, 3, 4, 5, 6. There are 6 things in each group. The answer to this division question is 6. Okay, let's look at that in a missing factor sort of way. So this is the original question we had before about the cookies to the 3 friends. And if you think about each friend receiving C cookies, that's the thing I don't know. Each friend receives some cookies. Then the 3 friends together, groups and things in groups, when I multiply those together, I should get 18. Well, I memorized earlier this year that 3 times 6 equals 18. That was one of my math facts. So I know the answer to this question, whatever that C is, it's got to be 6, right? Maybe as a 3rd grader, I'm not going to have a variable there. Maybe I'm going to have a box, or maybe I'm going to have a cookie shape or something. But whatever that is, it's equal to 6, which I thought about using multiplication. So I used multiplication to answer my division question. Okay, let's talk about inverses just a second. We know that addition and subtraction are inverses of each other. We know that multiplication and division are inverses of each other. So if multiplication can be illustrated by repeated addition, it would make sense that division could be illustrated by repeated subtraction. And that is the opposite sort of word problem. Okay, so look at this one. Again, I'm going to have 18 cookies. I'm going to have that same total number of cookies. And I want to package them in cookie boxes that hold 6 cookies each. How many boxes are needed? Okay, so how does this one fit with our definition of multiplication? What are the groups? Well, the groups are the cookie boxes, and that's what I don't know. The things in the groups, I have 6 cookies in each group. That's what I know. So with this repeated subtraction model, I'm given the total. That's true for both models. But this time I'm looking for the groups and I know the things in the groups. What I had last time was I knew the groups and I was looking for the things in the groups. So I'm in exactly the opposite situation here. Okay, so let's see if we can illustrate that using our blocks. All right, I have 18 cookies and I want to package them in cookie boxes that hold 6 cookies. I can't go 1, 1, 1, 2, 2, 2 like I did before because this time that's the question. How many boxes do I need? Well, I don't know how many total boxes I need yet, but I do know that each box that I create or each box that I fill should have 6 cookies in it. Okay, so there's 6 cookies. That is a box. All right, this is repeated subtraction because 18 minus 6 is 12. I took away 6, I subtracted 6, I have 12 left, and now I'm going to take away 6 more, or I'm going to subtract 6 again. So I'll group up 6 more cookies. These are going to go in my next box. Oops. So there, I have 6 cookies. There's box number 2. So 18 minus 6 was 12. And then I took that 12 and subtracted 6, and I should have 6 left. 1, 2, 3, 4, 5, 6, and I do. That fills up my third box. So the answer to this question is 3. So just like we had before, 18 divided by 6 is 3, but our thought process is totally different, and the way we're going to split out the blocks is totally different as well. Okay, so let's see what you guys can do. Write for me a word problem for 24 divided by 4 equals something. Again, the 24 is going to be your total. That's no different than what you did last time. But this time, I know the things in the groups, and I'm looking for how many groups. So 4 is going to represent the things in the groups. And what I'm looking for, the question there, is the number of groups. How many groups? Okay, so I want you to write a word problem for this one. I do not want you to use anything food related, just like before. I also do not want you to use the word group in your problem, right? If you look at this problem over here with the cookies and the cookie boxes, the word group is never used. You had to figure out about the groups. So I want you guys to model that same thing. Write me a word problem that has nothing to do with food and does not use the word groups. All right, let's illustrate the answer to your problem using the blocks. So I have 24 total blocks here as a little third grader on my desk. And I know I want to put them into groups of 4. What I don't know is how many groups I need. So how am I going to do that? How will I count the blocks? Well, I'm going to do repeated subtraction. I'm going to put 4 together. All right, and whatever you used in your word problem, that's group 1. Okay, let's do the same thing. And just for illustration, I'm going to pull these 4 from just random spots because it doesn't even matter. All right, so there's group 2. Now on your test, you're going to have to be more organized like this, right? You're going to have to pull in an orderly fashion so that you know how to label them. But for real, as a little third grader, it doesn't even matter. As long as you're putting 4 in each group, how you're putting them, what part of the line you're getting them from, that doesn't matter. All right, there is group number 5. And so those last 4 put together must be group number 6. So the answer to my question, I have 6 groups. The answer is 6. And remember we did that. We did 24 minus 4 minus 4 minus 4